Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the sixth part. In this part, we're supposed to determine the standard equation of an ellipse. We're supposed to graph it. We are given the coordinates of the two foci and the endpoints of the minor axis. Before we go over this example right here, let's have a review on the parts of every ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the A will be under the X. Now, we also remember that the value for A is always greater than B. And the equation that relates A, B, and C is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is H comma K plus minus C. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, going back to the problem right here, we are given the coordinates of these two foci, so we can change this 1 minus square root of 39 into its decimal form, and this 1 plus square root of 39 into its decimal form. It's going to come out negative 5.24, and then that is negative 4. And then this 1 plus square root of 39 is 7.24. And then we have a negative 4. And then we also have the endpoints of the minor axis. So I am going to plot this 4 points on this Cartesian coordinate plane. Okay, now we remember that the ends of the minor axis are actually the co-vertices. So I am going to write that down here. This tells us that this is our first co-vertex and this is the other co-vertex. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So we're going to determine the midpoint between these two co-vertices and the midpoint between these two foci. We can go ahead and say that this is actually the center of this ellipse. So our center is located at 1, negative 4. Since the two foci that we have here are horizontal, side by side, next to each other, then we can go ahead and say that this is an example of a horizontal ellipse. So I'm going to go ahead and label that up here. Since this is a horizontal ellipse, we can go ahead and write the general formula for a horizontal ellipse, that is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now notice that our a squared, which is the bigger value, is under the x, because again, this is a horizontal ellipse. So we can go ahead and say that since we are given the co-vertex, we actually have a value for b. Remember that the distance from the center to the co-vertex is represented as letter b. So I can go ahead and write that up here. So our b value is plus minus. We can go ahead and count it, or we can use the distance formula to determine the distance between these 2 points, or we have 1, 2, 3, 4, 5. So that is plus minus 5. This means then that our b squared is 25. So we already have the b squared here. So we can go ahead and rewrite this using our center, again represented as hk. So then this equation would come out x. This is a plus 1, so x minus 1. Because remember, we always switch, and that is a squared over. Our a squared is missing, so we leave that blank, plus y. This is a minus 4 or negative 4, so this comes out to switch it, plus 4. And then squared over the b squared is 25. And this is again equal to 1. So we're missing the a squared value. Looking at this problem that we have here, we are given the c. Remember that the c is the distance from the center to one of the two foci. And we also remember that since we have a horizontal ellipse, we have here also the coordinate of the two foci. We remember that for a horizontal ellipse, the first focus is represented as h minus c, comma, k, and h plus c, comma, k. So we can go ahead and say that our C value is negative 39 and also the positive 39. So this is our C. Now notice this very carefully. So you see we have 1, negative 4, 1, negative 4. Since this is a horizontal ellipse, we had to add the plus or subtract the square root of 39. So we can go ahead and say that our C is square root of, or that's a plus minus square root of 39. Since we wanted the a squared, we are given the c. We can actually solve for the a using the equation c squared equals a squared minus b squared. So I'm going to go ahead and write that equation up here. So we're going to plug the values in. So we are given the c value square root of 39. So I write that down here. So 39, that's square root squared equals our a squared is missing minus our b squared is 25. So write it down there. Square root of 39 squared is just 39, and that is equal to a squared minus 25. So we wanted to solve for a. So we're adding 25 from both sides plus 25. So then this gives us a value for a squared is equal to 39 plus 25 is 64. So I'm going to write that down here. So this tells us that our a is plus minus square root of 64 is 8. This tells us that we go 8 to the left and 8 to the right to determine the two vertices. So I'm going to go ahead and plot that up here. 1, 2, 3, 4, 5, 6, 7, 8. So this is the first vertex, and the other vertex would be 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. So this is the other vertex. So that we can go ahead and fill this complete this equation that we have here. So we already have an a squared of 64. So I put it in here. And so this is the equation that is the that would work for the problem that we have up there. So that from here we can go ahead and sketch the ellipse and determine the coordinates of the two vertices. So this is the equation that works for this problem right here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. So what I would do is to change this number that we have here, negative 2 plus 2 squared root of 6 and negative 2 minus 2 squared root of 6 to its decimal version. And I will plot this for points on the Cartesian coordinate plane. Okay, now we remember that these ends of the minor axis are actually the two co-vertices. So I'm going to go ahead and label that up here. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So looking at this, the midpoint between these two red dots and this two blue dots is located right here. So this is our center. So then we can go ahead and say that the center is on negative 3, negative 2. And since the two foci are vertical relative to each other, so this is an example of a vertical ellipse. So I'm going to go ahead and write that information up here. Since this is a vertical ellipse, I wrote the general equation of a vertical ellipse. Vertical means up and down, and so I wrote the bigger number, a squared, under the y. So that we can go ahead and say that the value for b would be the distance from the center to the co-vertex, which is 1, 2, 3, 4, 5. So that we can go ahead and write b is equal to plus minus 5. So this tells us that our b squared is actually 25. So that we can rewrite this equation as that is x. Remember, we switch and switch. So this comes out negative 3. So that's plus 3 squared over the b squared is 25 plus y, this is a minus 2, so that will be a plus 2 right here, squared over a squared is missing. We don't know what it is, so we just keep that blank. And so we have a value for C. Again, the distance from the center to the focus is C. Now we remember, since this is a vertical ellipse, this coordinate of the two foci here means that this is H, comma, K plus C, and this is H, comma, K minus C. So this means that this part right here is our C value. The other way to determine the distance between these two is using the distance formula, but this is the easiest way to determine the C. So our C is plus minus 2 square root of 6. So this means that we can go ahead and solve for a squared using the formula c squared equals a squared minus b squared, since we already have a b squared and we have a c. So I'm going to go ahead and show that work on the side right here. So our value for a squared is 49. So I can go ahead and write that down here. That's 49. And so this is the equation that would work for this word problem that we have up there. Now we remember that our A is the distance from the center to the vertex. So that means, since this is a vertical ellipse, I go up 7, down 7, and then determine the coordinates of the two vertices. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!